Have you ever wondered what's really going on inside your phone? I mean, it all feels a bit like magic, right? But behind every single app, every game, every website you use, there's a simple core logic at work. Today, we're going to pull back that curtain and show you the basic building blocks that make all software tick.
I mean, really think about it for a second. How on earth does your favorite streaming service seem to just know what you want to watch next? Or how does a game know in that split second that you've won or lost? It seems incredibly complex, but the answer is actually built on just a handful of tools that are, believe it or not, surprisingly simple.
All right, first up, we have the most fundamental tool in the entire box, the decision maker. You see, at its core, a computer program is just a list of instructions. But to do anything useful, it has to be able to make choices. It needs to react. And that's where conditional statements come into play.
So what is a conditional statement? Well, it's basically the program's ability to ask a question and then act based on the answer. It's the code saying, hey, if this thing is true, then I'm going to do action A. But if it's not, I'm going to do action B instead. This simple choice, this fork in the road, is the foundation of pretty much all digital logic. And this image here shows it perfectly. Just think of an if-else statement as a literal fork in the road for your code. The program gets to this point, it checks a condition, like a signpost, and depending on whether the answer is yes or no, it heads down one of two very different paths.
Let's look at a real example. Here, we've got a variable called age set to 16. The program then asks a really simple question. Is the age greater than or equal to 18? Well, since 16 is less than 18, that condition is false. So the code completely skips the allowed instruction and jumps right down to the else path, printing, sorry, you cannot enter. It's simple, it's logical, and it's decisive.
Okay, so a simple yes or no decision is great, but let's be real, life is usually a lot more complicated than that. What happens when a program needs to choose between, say, 3 or 4 or even 10 different options? Well, you just handle it with a chain of questions. The best way to picture this is like a waterfall. The program starts at the very top and checks the first condition. If that's true, it does its thing and then stops. But if it's not, the logic just flows down to the next question and then the next until it either finds an answer that's true or it hits the final catch-all option at the very bottom. And here's what that waterfall looks like in actual code. We use something called ELIF, which is really just short for else if. So imagine a student gets a score of 85. The code first asks, is the mark 90 or more? Nope. So it flows down. Is it 75 or more? Yes, it is. So the code prints, very good. And this is the important part, it then exits the entire block. It doesn't even bother checking the rest. It's found its answer and it moves on. Super efficient. All right, on to our second essential tool. And this one is all about automation. If conditionals are the brains of the operation, then loops, well, loops are the muscle. They are the tireless workers that do repetitive tasks over and over and over again so you don't have to. Now, there are two main flavors of loops. You've got the for loop, which you use when you know exactly how many times you need to do something like, say, process a list of 50 new user signups. Then you've got the while loop, which is for when you need to keep doing something as long as a certain condition is true, like a game that keeps running while the player is still alive. Here's a classic example of a for loop. That little piece of code, for I in range 5, is just a simple command that says, hey, whatever code is indented below me, I want you to run it exactly 5 times. It's predictable, it's controlled, and it does precisely what it says on the 10. The while loop, on the other hand, runs based on a condition. So let's trace this one out together. First, the code checks if x is less than 3. It is, so it prints the message. Then, and this is the crucial part, it increases x by 1. So now x is 1. The loop starts over, checks the condition again, still true, prints the message, and bumps x up again. It's going to keep doing this until x finally becomes 3. At that point, the condition is no longer true, and the loop finally stops.
And that brings us to a major, and I mean major operational risk. If you forget that little x equals x plus 1 part, that condition x less than 3 will be true forever. This creates something called an infinite loop, and it can freeze an application solid or even crash an entire server. For any business, this isn't just a simple bug, it's a direct threat to your system stability and your user's experience.
So our final tool is the organizer. Because once your code starts to get bigger, you absolutely need a way to keep things tidy, efficient, and manageable. And that is the job of functions.
I mean, it's a fundamental problem, right? Imagine you run an online store and you need to calculate the sales tax in 10 different places in your app.
Are you really going to copy and paste that same block of code 10 times? No way. It's inefficient, and if the tax rate changes, updating it would be a total nightmare.
This is where functions are an absolute game changer. You basically bundle a specific task into a neat, reusable block, you give it a name, and then you can run that entire block of code anytime you want just by calling its name. It keeps your code so much more organized, and it's how huge teams can collaborate on massive projects without stepping on each other's toes.
The key thing to get here is that it's a two-step deal. First, you use the keyword def to define the function. Think of this like building a new tool and putting it in your toolbox. It's ready to go, but it hasn't actually done anything yet. Then you call the function by its name, and that's the moment you actually take the tool out of the box and put it to work.
So there we have it, our three core tools: the decision maker, the tireless worker, and the organizer. Now for the really cool part, let's see how these simple ideas combine to build the incredibly complex software we use every single day.
This right here, this is the whole secret. Every single app, from a tiny calculator to a massive operating system, is built from these same three ideas. You'll have a function that contains a loop, and inside that loop is a conditional statement making a decision on every single pass. It's this nesting of simple blocks, one inside the other, that creates all the complexity and power of modern software.
So once you understand this core logic, you're not just a user anymore. You can start to think strategically about how technology actually works. These are the fundamental Lego bricks of our entire digital world. The only question left is, what would you build with them?